Unit 5, Video Lecture 2, Chemical Formulas. A chemical formula is a combination of chemical symbols that represent the composition of a compound. Examples are NaCl. We have the chemical symbol for sodium and chlorine. Other examples are CaOH2 and Al2SO4 3. Now, how do we determine a chemical formula? One way is to use the Lewis dot structures that we've been working with previous. If we take lithium, lithium has 1 valence electron, and chlorine has 7 valence electrons. Lithium is a metal, chlorine is a nonmetal. Lithium will want to lose its 1 valence electron, while chlorine wishes to gain 1. Now that lithium's given up that 1 valence electron, it will have a positive charge. Chlorine gaining an electron will have a negative charge. This will then cause them to attract, and we have our compound LiCl. Another example would be calcium and oxygen. Calcium has 2 valence electrons. Oxygen has 6. Again, the metal and the nonmetal will want to lose 2, while oxygen will want to gain 2 electrons. So calcium gives up 1 of its valence electrons to oxygen, and then gives up its second valence electron to oxygen. This means that calcium will have a charge of positive 2, while oxygen will have a charge of negative 2. So our compound would be CaO. If we look at calcium and chlorine, 2 valence electrons, chlorine has 7 valence electrons. So the metal still wants to lose 2, but this chlorine atom can only gain 1 electron. So this chlorine atom is happy, but calcium isn't. We're going to need a second chlorine ion to accept another electron. Now calcium has lost both of it, so it's happy. So our compound is CaCl2. Now, there's another way that we can do this without having to draw the Lewis diagrams for all of our atoms. Step number 1 would be to write the elements or ions with the positive charge on the left side and the atom or ion with the negative charge on the right side. So we will have our metal on the left and our nonmetal on the right. So if we look at our calcium and chloride, Ca and Cl. Calcium ion would be a positive 2. The chlorine ion would be a negative 1. Step number 2 is to crisscross the charges. So we take the positive 2 and put it with the chlorine, and then -1 and put it with the calcium. Step number 3 is to drop the charges. So we have Ca1, Cl2. Now, last step is to reduce. So when we have Ca1, Cl2, we don't need that one. So our final would be calcium chloride, CaCl2. So again, our rules for writing are to write the cation first and the anion second. Crisscross the charges, drop the charges, and then reduce. So let's practice. Lithium chloride. Step number 1 is to write the cation and the anion, including the charges. So Li +1, Cl -1. Step number 2 is to crisscross. So we have Li -1, Cl +1. Step number 3 is to drop the charges. So Li 1, Cl1. And then finally reduce. So lithium chloride is Li, Cl. Calcium oxide. Write the formulas. Calcium is a +2. Oxide is a -2. Crisscross the charges. Ca -2, O +2. Drop the charges. Ca2, O2. And then finally reduce. Since we now have a 2-to-2 ratio, that can be reduced to 1-to-1. So our formula is CaO. So barium nitrate. Write the formulas for the cation and the anion. Barium is a +2, and nitrate is NO3 -1. Now, since we have a polyatomic anion, we should surround it in parentheses as we're working through. So step number 2 is to crisscross the charges. So we have barium, -1, the nitrate ion, in parentheses, with a +2 down there. Step number 3 is to drop the charges. So Ba1, NO3, 2. And then step 4 is to reduce. We don't need the 1, so we have Ba, NO3, 2. Ammonium sulfate. Here we have 2 polyatomics. Ammonium and the sulfate ion. So when we write the formulas, including the symbols, we're going to put them both in parentheses. This is ammonium is NH4, +1, and sulfate is SO4, -2. Crisscross the charges. NH4, -2, SO4, +1. Drop the charges. NH4, 2, SO4, 1, and then reduce. So we have NH42 SO4. Notice, since we didn't need the 1, since we get rid of the 1, we can also remove the parentheses. Here, we still need them because of the 2. So, iron 3 chloride. When we write the formulas, including the charges, iron, according to the back of our periodic table, can be Fe plus 3 or Fe plus 2. The one that we use is because of the Roman numerals, we're going to use Fe plus 3. So we have Fe plus 3, Cl minus 1. Crisscross the charges, Fe minus 1, Cl plus 3. Drop the charges, Fe, Cl3, and reduce to Fe, Cl3. Aluminum sulfide. Aluminum is a positive 3, and sulfide is a negative 2. Crisscross, Al minus 2, S plus 3. Drop the signs, Al2, S3, and reduce. We cannot reduce the 2 to 3 ratio, so that is our formula. Magnesium carbonate. Magnesium is a positive 2. Carbonate, the polyatomic ion, is a negative 2. Remember, since it's polyatomic, we're going to use parentheses. Crisscross, so Mg negative 2, CO3 positive 2. Drop the signs, Mg2, CO3, 2, and reduce. So our 2 to 2 ratio reduces down to a 1 to 1. So since we are not going to, we only have one carbonate ion, we do not need the parentheses, so it's just MgCO3. Zinc hydroxide. Zinc is a positive 2 ion, and the hydroxide ion, the polyatomic ion, we're going to surround in parentheses. Crisscross the charges, so Zn minus 1, OH positive 2, drop the charges, and reduce. So we can get rid of the 1, however, we're going to have 2 hydroxide ions, so we're going to need those parentheses. Now, naming ionic compounds. Naming ionic compounds is fairly simple. Well, all we're going to do is we're going to name the cation first and then the anion. Remember that when we name a monatomic cation, we just use the name of the element. Monatomic anions, we're going to use the root of the word and then use the suffix IDE. So the Cl negative, chlorine, INE becomes chloride. If we have metals that form multiple oxidation states, or metals that have form multiple ions, we're going to use Roman numerals in the name. So PbCl2. This is going to take a little bit of work because we're going to have to work backwards. Okay? Now, we know that there's one lead and two chlorines. We know from our work that chlorine has a -1 charge, meaning that the total negative charge is -2. So in order to be balanced, our positive charge, total positive charge, has to be +2. So in this case, the lead has to have a +2 charge. So Pb +2 is the cation, meaning that the name is lead 2 chloride. So, pause the video and let's practice.